What I'd like to do in this session is talk about machine learning in the browser. When we typically think of machine learning, we think of using something like Python on the server, or maybe R, or a number of different technologies that we use to build machine learning models and to apply artificial intelligence for problem sets. What I want to do in this session specifically, though, is talk about how we use those things which are produced from TensorFlow or from a number of different tools like PyTorch when you build out machine learning models, and how do you consume them directly in the web browser. And if we have time, we'll also talk about how you can actually use JavaScript also in the browser or in Node.js to do those same kinds of things that you would normally do for building machine learning models using essentially TensorFlow.js, right? So that's what this talk is mostly centered around, which is TensorFlow.js, right? So as the introducer said, my name is Pratik Patel. I work at IBM, and one of the things that I work on when I have time is on IBM Watson. So everyone has probably heard about TensorFlow, right? That is from Google, which is their machine learning library that it works, like, obviously in Python, some other languages, and also in JavaScript with TensorFlow.js. And what we'll actually do a bit later is we'll take a TensorFlow machine learning model that's been built with Python and consume it and use it directly in the browser, which is actually very interesting, okay? But before we get to that, what I'd like to do is get into some machine learning basics and talk about why it's interesting to do this kind of stuff in a web browser, right? There are certain use cases, I think, which work really well for running in the browser or directly in the browser as opposed to on the server. And before we get started, how many people are already doing machine learning? Some level, okay, so a few people, good. So I'm going to spend the first few minutes talking about machine learning in general and just set some core concepts so that we can build upon that and do some demonstrations around it. Okay? So you probably know that machine learning is, at its core, is trying to make machines work like the human brain or the animal brain in general. Now, that's a very broad statement. And if you read on some of the things that are out there in terms of how do you use machine learning, how do you set things up to get trained models and things like that, it feels like it's fairly easy, but it's actually quite a complicated task. It's not something that you can go out and just say, okay, I'm going to learn machine learning today, and by the end of the day you'll know it, right? Not like a JavaScript library where you can just pull it down, and especially if you're using something not so complicated like Vue.js, which is what I'm giving a talk on later. It does take quite a bit of time to get your head around how machine learning works, and mostly it's around all the different algorithms that you have to apply to even get to a place where you can use machine learning. And it does take quite a bit of time. There's a lot of material online, actually, that allows you to get up to speed on machine learning. But at least for my personal journey, when I started getting into machine learning and trying to figure out what all the different things were and all the tools and everything I needed to know to be successful at it, it took several months, like 2 or 3 months. So it does take a fair amount of investment to be able to go and understand everything and know how to apply different algorithms and understand what neural networks are. And I'll cover that very quickly here. But I don't want to get too far into it because we could spend all day talking about TensorFlow and what are tensors and how do you do weighting and other things like that. But just in general, artificial intelligence is the broad concept of machines being able to carry out tasks in ways that we would consider smart, right? That doesn't really mean much. So we'll dive in a bit deeper and say machine learning is an application of AI where we should be able to give machines access to data and let them learn for themselves. Right? And this is why we're interested in machine learning as developers. It's because what we do as developers today is we use our own brain to go and solve a problem, right? Doesn't matter if the problem is something as simple as, okay, we want to go get some data from a database and show it on a web page, or maybe you're doing some business logic to extract patterns in data that your company's collecting or whatever. But the key here is that we use our brains to do that. The developer uses their brain to go and do those kinds of things. What we want to do, we want to get to a place where we can let the machine go and do some of those hard tasks that we may not want to do or we're just not simply capable of doing. Because a lot of times when we deal with problems, especially if you work in like high output computing or real-time computing, there are a certain class of problems which are difficult for developers to figure out, right? You have to have maybe an advanced degree in mathematics to understand things. If you work in financial services, for example, they employ a lot of people who are what they call quants, right? People who do quantitative analysis. These are folks who have PhDs in mathematics, and they understand set theory and category theory and all those different things, which is very advanced mathematical concepts. So at a certain point, we as developers want to be able to use what the machine can do and what these tools can do in the machine learning space so that the machine itself can go find patterns in data that we may not be able to see with our own mind, or go and do categorization of data, right? So those are two broad topics in the machine learning area, and lots of other different types of problems. Right? We'll cover some of those quickly here as we get through some of these slides. Right? So again, machine learning is software with the ability to learn with data without being explicitly programmed. Because what we do as developers today is we explicitly program algorithms to go and find patterns in data and go and find different things in data that we might need, or to do predictive analysis, right? Other things like that. And one of the key points here is that machine learning is only a subset of artificial intelligence. So we're not actually talking about everything that's in the overall AI space. Machine learning is only one subset of this. Right? If we have time, we'll talk a little bit more about some of the other subsets within artificial intelligence that programmers use today. Right? But broadly speaking, what can machine learning do? Or what do people use machine learning for today? There are a few things that you probably have seen before. Email filtering, right? That's basically going and having your email service going and detecting spam, for example, right? And if you ask me, so Google does this for Gmail. They use machine learning nowadays to go and basically find and filter spam. But if you ask me, they're a little bit too aggressive about it, because a lot of times someone will say, hey, did you get my email? I'm like, no. And then I'll go in my spam folder and it's there. Right? So obviously Google is still working on this because they haven't perfected the art of spam filtering, but that's one application of it. Another one is OCR, right? Optical character recognition. This is a very good use case for machine learning, especially because, and we'll talk about this in a second, there are two broad areas within machine learning that you need to know of. One of those is called supervised learning. So supervised learning is when you have some big ball of data and you know what the results should be, and you program something, you program TensorFlow to go basically from your data to the actual output. It's called supervised learning, but that's what OCR is, right? You have a picture that you've taken, or maybe you've scanned a sheet of paper with some words on it. You know what those words are because you can read them and you can verify that these words on the sheet of paper should be this. So that's supervised machine learning. And language translation, natural or human language translation is another area where there's actually quite a bit of work going on in the machine learning space to do this. So I'm going to take a quick aside and tell a little story about this. So there's, this is specifically around voice recognition, right? So we talked about language translation. If you use Google Translate, they use their underlying machine learning algorithms that they've built to do language translation, like from English to Hindi or whatever. But the really interesting use case recently has been around voice recognition, right? So all of you have a phone, and you can speak into your phone and say, order me a pizza or something, and it recognizes what you say, and your phone does exactly that. But if we go way back in history, about 20 years, there was a company called Dragon Voice Recognition, or Dragon Dictate. You've probably heard of them before. And they had a monopoly on all of the patents around voice recognition. So for years and years, voice recognition was not something that you would find in a lot of places because one company held almost all the patents, right? Again, this is Dragon Dictate or Dragon Voice, or now they're called Nuance. But what happened is this company, again, held all the patents. They had them for years, going way back into the 90s. And then during the .com era, they sold the company. So basically it was a husband and wife that owned the company. So they sold the company for $200 million in stock to another company, right? And they basically cashed out, or they thought they cashed out. And of course, this was the .com era. So they sold the company, and almost a year later, the company that they sold to went bankrupt. And so basically they got nothing for all the years and years of research they put into building these algorithms. But obviously those assets got acquired by somebody, and voice recognition is very popular, and it's very complex. It's a very complex field of engineering to be able to get really good voice recognition. So what the folks over at Google did a few years ago, so when you use Google voice recognition, for example, you are actually not using any of the patents from Nuance or Dragon. What you're using is you're using Google's underlying machine learning data sets that they have built up. So the way that they got around all these patents is they trained machine learning models, again, completely exclusive of all the algorithms that Nuance had built over decades to do voice recognition, right? So now when you use, if you have an Android phone and you use their voice recognition, you're actually using their machine learning algorithms behind the scenes, right? And in fact, it works so well that normally when you talk into the phone, like if you have an Android phone, a lot of the voice recognition is actually done on the device itself. Sometimes it actually sends it over to Google servers to do the voice recognition. But again, it's another application of machine learning. All right, so some other things that you can do with machine learning. Predictive analysis is a good one, right? This is, do they have Amazon in India? I can't remember. Is Amazon here? You can order, you can say, I want a box of batteries, and they'll just, you click the button and they ship it to you. Okay. So, for example, Amazon uses machine learning to do predictive analysis. So you know how you get that annoying email that, hey, you just bought some headphones. Would you like to buy more headphones? Yeah. And the answer is usually no, I just bought headphones. Why do I need more headphones, right? But anyways, they need to do some work on it. But that's what predictive analysis is. And actually, there's a really good story around this. There's a company in the US called Target. It's a big retailer, right? And they have big stores all over the US. Actually, Target is a Canadian company, isn't it? I can't remember. Yeah, anyways, it's a big retailer like Walmart, whatever. They have physical stores. And they use machine learning also, or they use some algorithms, let's say, some of which is machine learning, to predict what you may want to buy next. So there was a good story, I think about 2 or 3 years ago, where there's father and daughter. Father had an account. They had Target credit card or whatever, right? Rewards card, credit card. And father got an email saying, oh, would you like to buy diapers? Would you like to, buy basically baby products? And he was like, well, why am I getting this email to buy diapers or baby products? So what happened is, he didn't know that his daughter was pregnant, okay? And so she had been buying certain things at Target, and using their machine learning and predictive analysis, he was getting emails that, hey, you're having a baby soon, basically. Would you like to buy diapers and this and that, right? So again, we have to be a little bit careful about how we apply machine learning as developers. And there's actually an entire new field, is probably the best way to put it, around ethics around machine learning. So a very specific example of this is, I don't have the video unfortunately online, but there's a video of a hand dryer. You know how when you go to the restroom sometimes there's a blow hand dryer, you put your hand underneath to dry your hands. And there's a video where someone with lighter skin would put their hand underneath it and the hand dryer would turn on. But when someone with darker skin like us would put our hand underneath it, it wouldn't turn on. It was really, right? So again, we have to be cognizant when we apply, or when we're just doing development in general, but especially when we're training models to do certain kinds of things, we have to make sure that we understand some of the larger implications of how we're setting up and programming a system to learn on its own. Right? So again, that's the entire new area called ethics in machine learning, or ethics in artificial intelligence. Right? So along with this, it's pattern matching. Of course, you probably have seen examples of machines playing like chess or tic-tac-toe. Right? A lot of these also use machine learning algorithms underneath them. So take a step back for a second and think about what we do today as developers. Right? When our boss comes to us and says, hey, go implement this feature, or we're going to build this software to do this, right? What are some of the basic steps that we do? So we normally go and collect some data, we do some normalization, and we have this data that we're getting from somewhere. And then we have to go and clean the data and normalize it and look through it, and we have to basically get data ready to do whatever it is that our business wants us to do with it. And then once we have the data, we sometimes will do visualizations into the data. Maybe we'll do some graphs, or as a developer you might do something else. You may put it into a SQL database and run some queries to understand what the data looks like. And that process is what we call discovering insights into data, right? So we have all this data, we've cleaned it, now we want to iterate on it and understand what the data actually is so that we can apply it in some useful way. Right? So that's discovering insights. And then what we'll do is, now that we have this data, and say we want to do predictive analysis, we will go into our toolbox of algorithms and use different kinds of algorithms to come up with whatever our end goal is for processing this data and getting predictive analysis, or again, whatever we're trying to do. Right, so this is what we do today as developers, whether you're doing machine learning or not. Right, this is our basic process. So, with machine learning, thankfully, we still need humans and developers, because the first step is not something machines will be able to do for probably a very long time. Right, just understanding the data and normalizing it and getting it cleaned up and things like that. Those are things that you cannot do in machine learning today. It might be possible in 50 years from now, who knows, right? But the other two things, visualizations into data or discovering insights and algorithms, that is what the machine does for us today. That's what we can apply machine learning to, okay? That's the basic premise behind how we go and approach machine learning problems. So we still need humans to do data collection, cleaning, normalization. Right? Machine learning is not advanced enough yet to do that first step, and may never be, for that matter. All right. So I gave this example already. There are two basic types of machine learning patterns that you apply. One is supervised learning, the other is called unsupervised. Supervised learning is when you know what the end product should be, or what the end goal should be. Right? So an example of that is classification. Is this email spam? When you look at an email as a human, you say, yes, this email is spam, and you can mark it as spam, and when you give data into your machine learning algorithms, you say that this set of data is spam, this set of emails is not spam, and the machine can learn from what you have told it, right? It's basically like a teacher teaching a student that, whatever it is, right? Whatever subject you're talking about, like whether it's math or history or whatever, right? Supervised learning is like a teacher telling the student what to do. In this case, the student is the machine learning or a TensorFlow algorithm, and the teacher is you, the developer. Right? Another example of supervised learning is regression, which is doing predictive analysis or predictions. So if you get into machine learning, one of the first problems that you will work on is the Boston housing market data set. So they have this large data set of housing data from the Boston's a city in New York, you probably know, where they show like what house prices were with different economic indicators and things like that. And you typically work through some exercises where you build up a TensorFlow data model, and you go and run it through this, you build the model out, and then you plug in data, and it predicts what the house price should be in a specific year or under certain economic market conditions and things like that. But again, this is what we call supervised learning. Okay? Classification and regression are two of those broad categories. Supervised learning, again, is learning, like learning with the teacher. The machine learning uses training data, and we correct with the answers because we know what the answers should be. Okay? Right? And one of the interesting things about supervised learning is that at some point you, the developer, says, okay, the model is good enough now. We're getting 90% accuracy, 95%, 99% accuracy, whatever. And you eventually have to stop training the model because you say, okay, this is good enough, we're getting the predictive analysis or whatever we're doing at a specific level. So you know that this is good enough, maybe you don't have any more data, maybe you've taken it as far as possible, but you basically put a goal on and say we want to hit this level or get close to 99% accuracy, and then we stop going and working on training the model because we've reached our goal. Right? So when the desired correctness level is reached, we basically stop what we're doing in terms of training the model and working on refining it, etc. Okay, so the second broad category is called unsupervised learning, which is grouping users by behavior, for example, which is called clustering, or association. An example of that is people who buy X also buy Y, right? So again, two broad categories, and we'll dive into this a little bit more. But in unsupervised learning, we only have input data. We don't necessarily know what the answers are, right? So we'll have a look at the example in just a second, but something like this would be what you typically see in image classification, right? So again, if we go back 2 slides, well, 1 slide, sorry. If we go back a slide, we have clustering, for example, grouping users by behavior and association. And so clustering is the type of machine learning you use when you're doing image classification. So an example of that is, let's say you have 4 different kinds of fruit. You have a banana, you have a mango, you have a kiwi, you have an apple. And you take those pictures and you give them to a machine learning algorithm and you say, go and classify these different things into whatever they should be, so that when the model is trained, you can take a picture of an apple, give it to the algorithm, and it'll say it's an apple. Okay? So that's what clustering is. And this is what we call unsupervised learning. In this case, we know what the end result is, right? We know what an apple looks like. We know what a banana looks like. But again, the machine figures out on its own that these are the broad groups of different images that you're giving to me, right? Is this a cat? Is this a dog, right? Image classification is an example of unsupervised learning. And with the image classification, we may not necessarily, we know what the answers are, but there are other cases where we don't know where the answer might be, or what the answer might be. So a couple of examples of that, or one example of that is, aside from image classification, is when you look at a lot of work that's being done in machine learning in the health space, right? So how can we predict which group of people will end up with high blood pressure, right, for example. So in this case, we don't necessarily know what the answer is, always. We don't always know what the answer is, and there's obviously a level of correctness that we have to try to achieve with this. But again, that's an example where we don't necessarily know what the answer is, so we use one of these 2 things, clustering association, with unsupervised learning, and we let the machine figure out on its own what the answer should be. The basic premise is the 3rd bullet here, which is we observe and find structure in data. That's what the machine does. We could do this as a human. We could look at a very large data set and say, okay, this is what the structure of the data looks like, or some observations on the data, or we can give it to a machine learning algorithm and let it figure out what the structure of the data is. Because sometimes there's just too much data to look at. If you have millions and millions of records, a human can't possibly look at millions and millions of records. That's what the machine is for, right? And especially in this world, like, we're producing more data every year than has ever been seen before, right? So we always get more and more data. So here's some more examples of supervised learning, right? And this is what machine learning can do today. So, right, so we talked about this one. If we have an audio clip, we can transcript that audio clip and do speech recognition, English sentence to French. Again, language translation is one type of machine learning. And then, of course, all the rage right now is self-driving cars. And a lot of this stuff also uses machine learning underneath the hood to go and figure out, is that thing another car, or is it a bicycle, or is it a pedestrian? How do we go around it, et cetera, et cetera. Okay. So, and I already talked about this example of unsupervised learning. We have some input data, it might be fruit, we basically pass it into some kind of model, and it goes and classifies those things for us. Okay. All right. So, basic primer on machine learning, what the different types of machine learning are, categories, what are the use cases, how do we do all this fun stuff? Magic, of course, right? So this is where we as developers today can make a decision. It's like, well, I can spend months learning machine learning, and I can get into this area, and I can become a data scientist or a machine learning engineer or something like that. But you don't necessarily have to do that, right? We can actually just rely on people on our team who are data scientists to go and do these kinds of things. But just so you understand, example in just a second, but just so you kind of understand what goes into learning all of the different parts of machine learning, you have to have some kind of basis in algorithms and mathematics to be successful at machine learning. You have to know what's the difference between a Bayesian type of grouping and et cetera, et cetera. We'll look at some of those in a minute. And you also have to learn neural networks. So you have to get up to speed on just kind of basic mathematical and statistical algorithms. And you also then have to learn about neural networks, which is TensorFlow, for example. Right? So if we look at a neural network, again, this models the way that human brains work in some way, or animal brains work in some ways. Right? So you have some kind of input layer, and then you have some hidden layer inside where, as you feed data, the neural network nodes go and get weights and different types of values inside of them. And then at the end, we produce an output layer. And essentially, we feed new data into this, and it goes and activates something in the output layer. This is what's called a single layer neural network. And then most of what people do today is around deep learning, which is multiple layers in the middle, which are tuned by you, the developer, to go and achieve some goal, right? Whatever you're trying to do, right? So most people do deep learning. There are different types of deep learning here. So if we look at deep learning neural network notation, this diagram is actually from an online course, but it's right here in the corner. Unfortunately, you can't see it very well. A guy named Andrew Ning. He has a very nice set of courses actually on this, and most people usually start with his courses. But this is just some of the math that goes into programming and understanding how you build out a neural network. Okay. Again, I don't want to do a deep dive into this because this would take all day, but the basic premise is you have to know some algorithms, and you have to understand what a neural network does and how you can apply it. And that's what we're going to do here today, is we're going to figure out how to apply machine learning without becoming a data scientist. Right? We want to know just enough so that when we work with our colleagues and they say, well, we're going to apply a k-means algorithm and go set it against a linear SVC, right? We want to know some basic stuff so that we don't look completely stupid, number one, and at least we know how to consume the data or the machine learning model that we're given, right? So this is just an example of some of the algorithms which are in the Python scikit-learn library, right? So Python, one of the reasons why Python is actually so popular in the machine learning space, it doesn't actually have anything to do with machine learning itself. It has more to do with the fact that Python for years and years, decades, has been used by scientists because it has very good libraries for doing number manipulation. That's the only reason, actually. Right? So what's happened is, in the early days of Python, people built out really nice libraries for working with numbers. And then those got developed into things like scikit, right? Scikit-learn, and pandas, which is a library for working with data in Python. So Python, nominally speaking, is the gold standard in the programming world for working with data because they're great libraries for just working with numbers. And that's why TensorFlow is built on Python, because all those libraries have been there for doing statistical analysis and number crunching and other things like that. And it's kind of weird because Python is actually not a very fast language to do stuff in, right? Compared to Java or, of course, C++. Python is about, let's say, 2 to 5 times slower, but because all those libraries are there, people just use them. And of course, in today's world, we have so much computing power that it doesn't really matter if you use something a little bit slower when you have the utility to use these libraries right out of the gate, right? So anyways, the point is there's quite a bit to learn here, and it's totally worth your time to do that, but maybe you're just an application developer, or maybe you're just a front-end developer, and you're like, I don't want to get into all this, but I do want to know enough to actually apply some machine learning, and you can do that today. Right? So you don't need to be an AI or ML expert to actually use machine learning to do things. You just need to know some basics on how everything works, and then you can incorporate machine learning into your own applications just by getting these pre-trained models off the shelf that somebody else has built and using them in your app. And you do this today already. If you do image classification, you make an API call to Google, for example, or to IBM Watson, and you're using machine learning kind of at a distance, but you can actually incorporate some of these libraries directly into your app. And we're going to do that in just a sec here. All right? So again, we've talked about this already. Siri and Google Voice use ML. Google Translate is ML already. And the basic premise is that we go and just find models that are solving a specific problem that we need. We just pull that model off the shelf and we plug it into our application. We download that model and we just use it wherever we need to. Normally people use those models on the server, right? So you take a machine learning model, you load it up into Python, and then you have your server-side application, fed some data, and you do predictive analysis or whatever it is that you're doing. Right? But the basic premise is you can just download and start using the model once you know some of the basic rules. And that's what we're going to talk about now, is we're going to get into TensorFlow.js for a few minutes and have a look at a quick example of this. All right, so what's TensorFlow? I've talked about this already. TensorFlow is Google's machine learning platform. It is one of the most sophisticated platforms for doing machine learning. And what Google's TensorFlow specifically does is they model things in something called a tensor. And the tensor is what we would consider to be a neural network node. It's essentially a mashup of neural network nodes and data in a structured format. It has things like weights and different types of variables that are used to program each individual tensor. And we'll have a look at what one of those looks like in just a second, right? Or the output of one of those models. So in TensorFlow.js is essentially TensorFlow for the web browser. It was formerly known as DeepLearn.js. So now what you can do is instead of just being able to run stuff on the server in Python, right, you can also consume TensorFlow libraries in other languages like Java and C and etc. But now you can actually load a TensorFlow library directly into the web browser, and instead of having the computation done on your server, you can just do it directly in the user's web browser. TensorFlow.js can also be used to train a model, right? So we're only going to use it here to go and consume a model and run the model with some data to see what happens, right, to do predictive analysis. But you can actually also train a TensorFlow model directly in the browser. So if you go to the TensorFlow.js website, one of the things that they have is you can hold up like an item and use your computer's camera directly in the browser to do image classification. So switch on the user's camera in the browser, and you can hold up an item, and you can actually program an image classifier directly in the browser if you wanted to. Okay? There are other things you can do. You can basically anything that you can do, not anything, most things that you can do with TensorFlow, you can do directly inside of TensorFlow.js in the browser. So you don't need to have a very, very large, basically a compute farm to be able to run this stuff. You can actually distribute it across all of your users' actual desktops or laptops or whatever. So you can kind of do distributed TensorFlow programming or model training using TensorFlow.js. All right, but before we jump into that, why are we interested in doing ML in the browser? Well, one answer is called Atwood's Law. So have you heard, who's heard of Atwood's Law before? Anybody? A few people, right. So Atwood's Law was coined by a guy named Jeff Atwood, and he said that any application that can be written in JavaScript will eventually be written in JavaScript, right? So it's a little bit of a, maybe a little bit of a joke, but it is very much true. I think I've seen, they have like, what's the specific example? They have like MS-DOS running inside of your web browser, programmed fully, like an entire operating system, MS-DOS running in the browser, and lots of things, right? There's lots of stuff in the JavaScript world. Sometimes you're wondering, why would you do that? But anyways, so ML in the browser. One of the reasons we want to do this is that we don't have to go to the server, right? Everything can be just done directly in the browser. So there's no round trip to the server, so that means it's super fast. The other thing, as I mentioned before, is that we can offload the work that we want to do to train a model or run a model into the browser. So you don't need to have a large compute farm to be able to go train a model anymore or to go and run a large TensorFlow data set. You can just do everything directly in the user's browser. So that means it's fast because it happens in the browser, and also we've offloaded it so that we don't need to have a lot of money to power a compute farm to do the training or to run a model. Okay? All right, so let's do a quick demo. And I did load this demo up just in case I didn't have internet. So let's have a quick look at this demo right here. Let's make this full screen. So let me talk about this demo for just a second. All right, so this is what we call sentiment analysis, right? Kind of like kind of doing like predictions. And the specific data set that's used here is the IMDB reviews data set. So IMDB is the Internet Movie Database, right? So if you go to imdb.com, or if you ever search for a movie, it's usually the first hit. Right? What they did is they went through tens of thousands of different reviews on IMDB, and they came up with the machine learning model that predicts what score the user will give it based on the review that they write. Okay? So let's run this really quickly here. Right, so I'll show the code for this in just a second, but if you see here, I've already loaded the trained model in the browser, and what I'll do here, let's make this bigger. Okay, there we go, that's better. Right, so I will say, what movie came out recently? I haven't been to the movies in a while. Avengers, okay. So I thought the Avengers movie was excellent. Okay? So based on this text review that I've written, you can see that it gave it a score of 10. 10 out of 10. Okay? If I come into here and say, I thought the Avengers movie was not very good, you can see that it gave it a score of about 1. A 1 out of 10. All right? So let's go and add some more stuff here. Let's just type in some random stuff here, basically. When I went to see the movie, my car broke down, and I had a hard time getting to the theater on time. The movie itself was just okay. All right? So you can see as I typed that out, it gave it a score of about 6 out of 10, which, based on the words that I've typed in, sounds about right. I said the movie was just okay. Right? So it's like, maybe I'll give this a score of 6 instead of whatever. Okay? So in predictive analysis, let's go have a look at the code for this real quick. To find the right code.
Any questions?
Yeah, exactly. We're done. Any questions? All right. So how many people are familiar with React? Anybody? Okay. Fair number of people. So this is just a React application, and this doesn't have to be a React application. You can use this in anything. Right? I could have just written this with plain JavaScript if I wanted to. But I just decided to write this specific example in React. It's not a very complex example. So let's go look at the core of the example real quick. What is this saying? Nope. Okay. So here's our React example. This is just using standard React components, as you can see here. Well, actually, it's using React Bootstrap. And let's go have a look at what the UI definition is, right? So there's text sentiment analysis, which is this thing right here. And I have my text input right here, which is this box. And then at the bottom, I printed out the score and how long it took to do that specific thing. So if we scroll into here, you can see that this took 7.5 seconds because that's how long it took me to type it, right? But let's do something really quickly. I'm going to cut that, and if I just paste it in, well, unfortunately let's actually open this. Nope, not going to refresh that. Okay, so let's go load the trained model, and let's go paste it. And you can see that, oh, that's not the right paste. Let's try that again. Okay, so let's take our little review here, and let's reload this. Let's load our trained model, and you can see it took about 200 milliseconds for the model to actually execute and get to this result. So it's not too bad, right? Not super fast, but it's going through a fairly large data set here. Right, so let's have a look at how we actually do this. And you can find this example on my GitHub repository. I'll show you the repo in just a minute. But let's go actually look at what we're interested in. Is I actually wrote a small library that you can just import so you don't have to write all this stuff yourself. That goes, in this case, I'm just loading it locally, or I could go get it from directly from the Tensorflow.js models library. So again, this is the IMDB sentiment analysis. The CNN here, let me make that a little bit bigger. All right. The CNN here means that this is what we call a convoluted neural network. So there are different types of neural networks. There's like Russian the multi-layered convolutional neural networks, et cetera, but this specific model was built using a CNN, and that doesn't really have any effect on us actually using it. We're just using the data set, right? Again, our goal is just to be able to use something without being a data science expert, right? We just want to do some predictive analysis on when people write a review, so let's just use this model to do so. But let's see how this is actually used. So we have a model and we have a metadata. We'll hop into that in just a second. So inside of our application, app.js, you can see I do some initialization inside of here to go and set the state and other things like that. But right here is where I go and load the TensorFlow model. So if we go look at the model, the init model goes and loads this pre-trained model. So we're using the TensorFlow library, which is right up here. So the TensorFlow.js library is just something you can go and grab. It's an NPM. So you just do npm install TensorFlow, and we'll go install TensorFlow.js. Yes? Yeah, go ahead. I'm sorry. Oh, I see. It's washed out. Okay. This will be fun. I've never done this like in a live demo, so. Yeah, I was hoping there'd be a shortcut for it. Where is the settings here?
I think under the intelligent menu is some preferences.
Oh yeah, I'm looking in the wrong place. Okay.
And then under, I think, themes or appearance. You just look at themes.
There it is. Start again. Yay! In-flight demo. I did say that this demo may not work, right? Remember this graphic? So anyways. So we go and load, we have the TensorFlow.js library, which we just do npm install TensorFlow. That'll install into our project. And then we use the TF library to go and load the model, right? That URL is essentially this thing right here for the model. And once we have that, we go and load the metadata into our application like so. Right, so we just say go and you can just copy all this. Relatively straightforward in terms of the number of steps you have to do to load everything. But this is where we do our prediction. So once we have our TensorFlow model loaded, we say go and predict what the output should be for that specific model. And then when we get the prediction out, we go and grab some data from the inside of it, which is this score. Okay? So there's really not much to see here except for the fact that we go and load a model. We have to go set it up to be ready to go do something, which is this stuff right here where we say go and load all the data from our model. We'll look at the model in just a second. All right, and then when we want to go and run the model, we basically go and get all the words that I typed into the web browser here, and we feed it into that TensorFlow model to go and get the score out of it. All right? So, and we return that score, and then if we go back to our app.js, that is when we go and say get the prediction score, which is right here whenever we type something in real time, go and get the prediction score, we go into our React application and we just execute TensorFlow.predict, which again is this function right here. It goes and pulls all the words apart, it feeds them into the model right here, and then we get the score out of it like so, and then to get that, how long did it take? We're using this performance, which again is built into the TensorFlow library to let us know how long it took TensorFlow to actually execute the model. Okay? And now, let's go look at the model. This is what the model looks like. Right? The model is actually not very interesting in terms of how it's actually set up. If we were to go into here, you can see that this is using a number of different tensors. Where is our tensor? Right, so this is the configuration. And again, we don't need to know all of this, but here basically are our different weights for the models, the tensors that we have inside of this application. So it's actually just a single layer neural network, not multi-layer. And the interesting part in this is the metadata. So as part of this convolutional neural network, what it did is it constructed inside of each of the tensors what the weight is assigned to every word. Right? So if we say, if we just go search for bad, well, that's not going to work. Let's go find another one. right? So for each word that was seen when this model was being trained, it assigned it a specific weight, and that's what this massive file is. It basically takes each of the words and assigns a weight to it, which is then fed into the TensorFlow to go and set up that neural network to give us a score at the end of it, right? And you can see this is a massive file. I don't know how many lines long it is, but we'll find out in just a second. Right? It's about 80,000 lines long. Okay? But anyways, this is the model. This is what we did. Now, one thing interesting about this is, like, if I just come into here and say, I thought this movie was not so great. What? That doesn't look right. Right? So one of the limitations of this model is because it's only looking at the words that are typed in there. It doesn't actually look at the sentence structure that we put in. Okay? So this is not actually a great model for doing text-based predictive analysis because it doesn't take into account sentence structure. It only takes into account the actual words which are typed. So you can see I typed in, I thought this movie was not so great. Right? And in English, that means I didn't like the movie, so it shouldn't have a score of 1. It should have a score of maybe 2 or 3 or something like that. Okay? So one of the things to watch out for is when you're using these different models that you find online or repositories which contain these models. So this is slowly starting to happen, actually, where people are building pre-trained machine learning models to solve different kinds of problems, and you can just either go get them for free, or you can actually buy these models on a marketplace. Remember, our goal as application developers not to be a data scientist. We just want to consume these machine learning models and use them in our own application to solve a specific problem. Whether it's text sentiment analysis like this, or predictive behavior, or like if we work for a company like Walmart or Tesco or something like that, we want to predict what the user will buy next, we can probably find models to at least start with and build upon to build our own types of things around this, right? We just want to consume the models. But we have to be careful because a lot of these models come with caveats. They have very specific restrictions or rules that they built the model on. Sometimes we call them assumptions. Right? So the assumption in this model was we're just going to look at the words that the user types in, not necessarily at the entire sentence that somebody types in. Okay? So, anyways, let's see if we have another example here. We'll go back to the code real quick. Yeah, I don't really have anything else that's interesting in terms of the overall kind of performance of this, but we do have a little bit of time for some questions. So any questions, or is this something that we want to try? Yes, sir, go ahead.
Yeah, so from what we've seen in the demo, it seems to be a fairly good ROI application. If I want to scale it up to a real enterprise app, that kind of an enterprise data set.
Right. So I think the question that you're asking is, what happens when you have a larger data set, or like something that's a little bit more real world, right? How big would that model be? The short answer is that it really depends. So in this case, let's have a look and see how big this model was. Where did I put the model? I think I had it in here, didn't I? Sorry. Just go double check right through the model in here. Okay, it's in the public folder. Okay, so let's have a look. Make this a little bigger. Okay, so there's our metadata on our model, and in this case, the model looks like it's about 2 megabytes in size, right? So depending on what you're doing, right? If you're doing something that's very data heavy, like image classification, the model will be large, but it won't be huge. For other things, again, because we don't need the entire data input that was used to train this model, we just need to know what the weights and some of the metadata around the model was, right? If you remember from a second ago when we looked at the overall model, it was actually not very large, and the weights were in there. In this case, the metadata was very large that's attached into that model, right? So sometimes it can be very small, actually, and sometimes it can be very large. If you're doing like image processing or like speech processing, yes, it will be on the larger side, but it won't be huge. It won't be like, it won't be in the gigabytes. It might be in the hundreds of megabytes, right? And you can actually load hundreds of megabytes worth of data into the browser. That is not actually a problem. It's when you start getting up into the gigabytes, because what happens, obviously, when we run this, so if we go back to the output or our data here, right? So when we run this, go and get the metadata, we go and fetch it, right? We're essentially converting this in, from the file into JSON. So this is actually creating a massive JavaScript object in memory. So yes, it will use a fair amount of memory inside of it, but again, most models won't be in the gigabyte range. They may go up to the hundreds of megabytes, which is safe to load into the browser. You won't blow your browser up, or the user's browser to do that. That was your question, right?
Yes.
Okay. All right. More questions? Yes, sir.
So when you talk about browser, right, all browsers are not going to be the same.
Yeah.
When all these technological advancements, it comes to Chrome first. Then
Right.
maybe Safari and Firefox and
Yeah.
Internet Explorer lags a bit, and then there is this whole mobile devices. So if I open the same thing on my mobile, so if it's going
Right.
to consume that much JavaScript object memory in a mobile device, right?
Yeah.
It's going to really blow up, or it's going to be very slow.
That's right.
So is there a way where we can, normalize it or cater to different devices and different browsers, how this works?
Yeah. So the question is if we have a large data set and we need to load it into a browser. Browsers are different on the desktop, and then you have mobile browsers which have even less amount of available memory. So again, I think most of this is okay, because if you think of what the component cache is on a mobile browser, on a modern mobile browser, like say you're on a newer version of iOS or Android, the component cache generally tends to be in the hundreds of megabytes in size, right? So between the TensorFlow library and the model that you're loading, you're still only within the hundreds of megabytes, so you can actually still load this. Let me go look at I don't know how big the TensorFlow library is. Let's go have a quick look. Drop into our command line real quick and see how much of the internet that this thing downloaded. All right, so there's I don't know why there's an @ sign or TensorFlow. And there's, let's just do a really rough calculation on how big it is. Okay, so you can see actually the TensorFlow lib is actually quite small. It's only like, even if you load the core and the layers, this is a total of what, maybe 8 megabytes in size? And then our model was another 2 megabytes for this small one. But again, if you think of the component cache in a mobile browser, you still have the ability to load hundreds of megabytes. Because when you use Angular, it uses easily 2 gigabytes of memory in your browser. That's a joke, by the way. Right? So, because Angular is huge when you load it in the browser.
It's a different memory, right?
What's that?
So the one that you showed the demo, that
Yeah.
model is maybe a pretty small one.
Yeah.
But for an image processing or predicting whether your car sensors are good, so those models may be
That's right.
size, correct?
They will be much bigger, but again, typically they'll only be in the hundreds of megabytes range. So it's actually safe to load it in the browser. I think the bigger issue would be, does a mobile device have enough compute horsepower to actually run the model in an efficient way, right? So that would be a bigger problem in my mind, rather than loading up this large data set. So, yeah, it's a good question. Yes, sir.
So, in these examples, these are very, one computer, one browser based. Is there any where there can be collaboration
Right.
between multiple browsers, or is it
Yeah.
the wrong direction to think?
No. Okay, so the question is the demo I've shown, and most of the demos you'll see, is a single computer or single web browser doing something. Is there a way to basically distribute that? And this is actually a really good question. So say you want to deploy something to all of your users' browsers where they help you train some kind of data set in their browser. You basically are using the user's computer and CPU and memory to train a data set. How do you merge those data sets together? You're doing distributed computing in the user's browser. So the short answer is that you can do that, but there's no pre-built mechanism or library. You have to code all that yourself today. But what people typically do in this case is say that you want to use the user's browser to do some image classification. So you load up TensorFlow, you have them do stuff or just like show pictures or whatever, right, in the user's browser. as you're building out that TensorFlow model in the user's browser, at the end what you want to do is you want to upload it to some central location and merge it with the other ones. Because the way TensorFlow is constructed, even though it's a little bit complicated underneath the hood, it's actually, the data structure is not very complicated. It's basically, as you saw in the quick look I did, is basically weights and other variables that define what that tensor has actually done, or what the tensor has learned. So you can actually take different tensor data and merge them together very easily. And there are tools to do that in Python, but you can't do it in the browser. So in terms of distributed computing, you would have to have the user upload, or maybe you just have like some kind of WebSocket where at the end you just or you just send data like in the background as people are doing something or training a model. But you have to build all that. That does not come out of the box with it. So, okay? All right, I think we have time for one or two more questions. Yes?
Download onto the browser. Part resides in server.
Yeah, so the question is it possible to do a hybrid approach where some of the model is on the server and some of the model is on the browser? The short answer to that is no, not really. Again, it depends on how you structure it. Typically, when you have a TensorFlow model, it's one entire model, right? And you have to feed that model all the data that or whatever you're doing with it. So it all has to be together. You can't split it apart, really. So it doesn't really make sense to split it apart in the way the tensors work. So, okay. I think we have time for one more question. Yeah. But yes, sir. TensorFlow with PyTorch. So I actually really like PyTorch a lot. And I'm not just saying that because IBM Watson uses PyTorch. IBM Watson can use either PyTorch or TensorFlow, right? For me, I really like TensorFlow because it has enough sophistication and complexity inside of it to be able to address a large number of use cases for machine learning, but so does PyTorch, right? So I actually like them both. I end up using TensorFlow more because there's just a lot more, stuff out there around TensorFlow, right? PyTorch is popular, but it's not nearly as popular as TensorFlow. So you can find a lot more kind of information and like samples and et cetera for TensorFlow as compared to PyTorch. So, okay? All right, thank you for coming. We're out of time. If you have more questions, I'll be happy to take them up here. Thanks, everybody.